Part B. Measurement of acceleration. Steps to be taken. 1. Increase the slope of the ramp. 2. Do a test run to see that the spaces between the dots of the ticker tape increase during the motion. If not, further increase the slope of the ramp. 3. Ignore the first 5 dots and cut the tape for every 5 dots. 4. Paste each strip of 5 dots on a graph paper. Note how the length of the strips changes with time. 5. Tabulate the value of change in S divided by change in T for each strip and plot a graph between change in S divided by change in T against the change in T and calculate acceleration from the gradient of the graph. 6. Note the shape of the graph. If it is a straight line, it means the acceleration is constant. Precautions. Ensure there are no external forces acting on the trolley. Reduce the effects of any friction by setting up the runway in a horizontal position using smooth wooden surface and, if necessary, by providing a small incline for the ramp. Ensure that the voltage rating of the timer is not exceeded. Ignore the initial 5 or 6 dots on the tape since the trolley may not be moving with constant speed or acceleration during this time interval. Also, in counting the ticks, use 1 tick where you start counting as a reference tick and count the rest 5 or 10 ticks for calculations. Discussion quiz. 1. What type of collision is represented here? Answer: inelastic collision. 2. Was momentum conserved? If the answer is yes, what will you do to verify it? Answer: yes, momentum was conserved. We will determine mass of trolleys A and B and apply the equation of conservation of momentum. 3. Was kinetic energy conserved? Answer: no, kinetic energy was not conserved. 4. If the trolleys rebounded instead of staying together after the collision, what type of collision will it be? Will the kinetic energy be conserved? Answer: elastic collision, and the kinetic energy will be conserved. Summary. Let us recap what we have learnt. Momentum is the product of the mass of an object and its velocity. Momentum is a vector quantity. From Newton's second law of motion, we link force as the rate of change of momentum. The law of conservation of linear momentum states that total momentum before collision is equal to total momentum after collision. Quiz. 1. State Newton's first law of motion. 2. Define linear momentum and state its units. 3. A boy catches a cricket ball of mass 0.15 kilograms, which has a velocity of 20 meters per second. A. Calculate the momentum of the ball. B. Calculate the average force used by the boy's hands to stop the ball in 1. 0.5 seconds, 2. 0.01 seconds. Can you explain why stopping the ball in 0.1 seconds hurts the boy, but stopping in 0.5 seconds does not?